First thing I want to show you, is what is a vibration. We talk about vibration, we teach about it, and yet I'm not sure we really understand what it is. This is a conventional description of a sine wave. It is what we generally consider in standard engineering what a vibration is. Where we've got a positive phase to a vibration and a negative phase to a vibration, and in the center we've got a neutral phase for these vibrations. Now, in my study and working with Keely for over 10 years trying to understand what they were doing, this is a graphic representation of measurements. It is not a vibration. It is a graphic representation of changing amplitudes. If we have a point source over here for sound and the sound's traveling in this direction, and we've got a microphone at any position in here, the rarefactions and condensations of the air waves, as the sound goes through the air, that's what sound is. It's a rarefaction and compression wave. This is what compresses the particles together of the air, and this is what is when we have a rarefaction. Okay? So as it passes the microphone, we get an up and down measurement. The meter goes up and down, but it doesn't really tell us anything. Okay, so what's happening is we've got an expansion and a contraction. The expanding radiating force, that's what the ancients called a male force. It goes out, it radiates out, it impacts things. It's like the sledgehammer approach we use in physics today. You've got to put all this energy into a system to get anything back. And that's only a third of the story. Another third of the story, or almost the whole half of it, is the female side of this vibration. That's this side down here. This is the rarefaction. This is once it expands out, then you get the collapse. The collapse is that female force. What is it that causes this collapse? Here's a whole field of science modern science is ignoring. They don't even acknowledge it. They're just beginning to. They're beginning to suspect that there's something there. Just like women's liberation is just now beginning to happen. We're just now beginning to recognize that women exist. It's really strange. But the parallels in philosophy and science and life, they are absolute. That's the way it works. Negative attraction. So here we go. We got radiating propulsive force going outwards. We got an attracting force that comes to the center. So it's a positive propulsive going out. It's a negative attraction coming in. So the negative attraction is the female force. And that's the basic principle behind that and what it is. So we got the night side forces. That's negative attractive. The ancients Casey talked about that quite a bit. The night side forces. The Atlanteans, the stories go about the Navaz energy. That's night side force. The dark side forces. But they aren't evil in any way, shape, or form. And because one's positive and the other's negative is not one's good or bad. It's just two polarities. It's like a coin. You can't have a coin with one side. It's got to have two sides or there's nothing there. So it's the other side of the duality of mankind. Mankind is a neutral characterization of a duality, male and female. Okay. So we got the forces. In fact, I had a chance to talk to a nuclear scientist. He was a retired Army. He died a few years ago. But he used to design nuclear weapons. And we got to talking about it. And he said, you know, it's not the explosion of this bomb that's destructive. It is the implosion after that explosion has taken place. That implosion to the center of 0 point is what causes all the destruction. The negative force is where all the force is that we really need to deal with. It is a gentle force. It is a nurturing force. It is a subtle force.
But this is really the yin and yang of family.
Yin and yang, that's exactly right.
You take those two spheres, you put them together, and you put them in.
That's right. In fact, I've got a real neat design here that shows these. These dynamic forces. In this chart, I kind of did a little playing around with it, but over here we can see the three particles within this, by the way, let's start in the beginning, or we're going to get you lost. This is a simple molecule in Keely's morphology, his molecular morphology. This large thing is what he called a simple molecule. It's not a complex molecule like a plastic molecule. It's just a simple molecule, within which are three what he called inner molecules. That's what these three in the center are. Every particle, he said, had the same configuration. It's the internal constructs which are different. Inside each of these is another three, and inside that another three, on down to infinity. And this is the root of this science. This in another chart This drawing was originally published in 1886 by John Keely. This is modified. I just redrew this to have this transparency. But we can see that we've got the molecule, the inner molecule, the atom, the inner atom, on down to 8 levels. Keely built machinery to investigate these 8 levels of material substance. Now, in these 8 levels, he got to the 8th level, and he says, I can't build machinery fine enough to investigate the 9th level. So he referred to the 9th levels as the infinite ninths. They went infinitely beyond his capability of investigating them. Now, correspondence with today's science, I can show you that. This is a revelation. These are my 2 best charts. And these are fundamental to understanding this science. We're going right to the heart of this one real quick. What we have, here's the molecular level, the largest circle, the intermolecular atomic, etheric, interetheric, all the way to the infinite ninth. Now this is Keely's development right here. The ancients called it earth, water, air, fire, ether, mind, and God was the infinite ninth. And in modern science, solid, liquid, gases, plasma, photonic, quarkian, and from there it's a guess as to how they put all this thing together. But we know modern quantum mechanics says there's 3 quarks in a photon, and there's 3 photons in an electron. That's modern quantum physics, guys. And we got the same chart that Keely had over 100 years ago. Now what this means is the larger the item, and this is basic acoustics, for those of you who know anything about sound, the larger the item, the longer the wavelength, the lower the frequency. So the higher we go up these levels, we get shorter and shorter wavelengths, and we get higher and higher energy states. Keely maintained 30 years before Einstein that the faster something moved, the more compact it got. And the more compact it got, the more energy it contained. When Einstein hit the scene, he plagiarized all these things, and he wrote it like this. That's what he said. Energy equals mass times speed of light squared. But he stopped at the electronic level. If you go into the quantum level, which he hadn't gone into, this doesn't necessarily apply in this particular way that it's phrased. But what this says, the faster something goes, the higher the energy content. That's what it says. So you get down here, the faster something goes, the greater the energy content. So these smaller subatomic elementary particles have greater energy content than the grosser, more mundane, more material items such as molecular matter. So here's we're slowly approaching to a definition of this negative attractive energy and these subtle energies that are used in radionics. This is where we're trying to get to. So having established that premise, and please interrupt me with questions. Anybody got any questions? Please just jump right in because we may cover a lot of stuff too quick.
These are available, charts, right?
Beg your pardon?
Charts and photographs are available.
They are available?
I'm asking you.
Yes, they are. I have some books on it at the book table. I also have a computer program. I spent 10 years putting this computer program together. It's got 11 megabytes of this information in it and all related types of information. It's a vast, vast field, and I don't think any one man could ever master it. So we say, how does all these things connect together? And I'll show you that. It's really simple. If we have 2 items down here that